Welcome back, everyone. Let's continue to talk about some basic concepts of probability. The last time we were together, we talked about 3 different views of probability. We discussed the subjective view of probability, the frequentist view of probability, and the analytic view. I mentioned that the analytic view was all about computing probabilities based on various assumptions. And those are very reasonable assumptions. For example, when we're talking about flipping a coin, we can make the assumption that both heads and tails are equally likely to occur. Based on that view of probability, let's learn a 3-step procedure to compute some simple probabilities. Let's keep talking about that example of a coin toss, and then we'll go through some other examples. The first step of the 3 is to count the total number of all possible outcomes. Now think about this. When you flip a coin, there are really only 2 possible outcomes. It can turn out heads and it can turn out tails. Let's move on to step 2. Step 2 says, among all the possible outcomes, among those 2 outcomes, count the ways that event A can occur. When we're talking about event A, that's the event that you're actually interested in. So let's just assume right now I'm interested in computing the probability of flipping a coin and having it come up heads. So that would be event A. So among all the possible outcomes, heads and tails, how many ways can heads come up? It can only come up one way. At that point, once we have those 2 pieces of information, we can estimate the probability of flipping a coin and having it turn out heads. We'll just remind ourselves that heads can come up only one way and that there are 2 total outcomes possible. So that fraction is going to end up looking like this. There's one way that heads can actually come up out of 2 possible outcomes. And of course, 1 divided by 2 is 0.5. So the probability of flipping a coin and having it turn out heads is 50%. That means over the long term, if you were to flip a coin and flip a coin and flip a coin and keep flipping a coin, about half the time, 50% of the time, it will turn out heads. So let's keep this simple formula in mind, this simple fraction. With that simple fraction, we can compute almost any basic probability. We'll compute the remaining probabilities together. They're all very simple, very straightforward. In another video, we're going to learn a few rules of probability, and then we'll be able to compute some probabilities that are a little bit more sophisticated. Here's that simple formula, that simple fraction. We'll use that basic setup to estimate some simple probabilities. Again, we just want to count the number of ways that some event can occur, the event that we're interested in, over the total number of all outcomes. We already looked at the probability of flipping a coin and having it turn up heads. Let's look at this next one. Actually, the next several are all focused on a deck of cards. Let's make sure we understand the basic properties of a deck of cards. We need to understand the properties of a deck of cards in order to make some assumptions about it. You might recall that a deck of cards has 4 suits: hearts, diamonds, spades, and clubs. Within each suit, there are 13 cards. So if there are 13 cards in each suit, that means there are 52 cards overall. All right, let's just keep that in mind. Let's say we start off with a full deck of cards, 52 cards. What's the probability of randomly selecting a king? Well, remember, we're going to set up a fraction, so I'll just go ahead and draw a line. Let's talk about the numerator of that fraction. We need to determine the number of ways that a king can occur. Well, there are 4 different kings because there's a king of hearts, a king of diamonds, a king of spades, and a king of clubs. So there are 4 different ways that a king can occur. And then we have to figure out what are the total number of all outcomes in a deck of cards. So when we randomly select a card, how many different cards could come up? How many outcomes are there? There are 52 overall. And there you have it, my friends. We just need to compute the final value using our calculator, but it's that easy to set up the calculation for a simple probability. 4 kings divided by 52 cards overall would give us a probability of about 0.076, which we'll just round to 0.08. 0.08. So about 8% of the time, when we randomly select a card from a full deck of cards, we will find a king. Next, let's figure out the probability of randomly selecting any face card. Let's be clear here. In this particular case, the only cards that we will consider face cards are cards with a face on them. So we're talking about kings, queens, and jacks. Remember that in a deck of cards, each one of those cards, like a king, occurs in each suit. So there are 4 kings, 4 queens, and 4 jacks. 4 plus 4 plus 4 would be 12. So there are 12 face cards overall. So that's going to be in our numerator. How many ways can a face card occur? It can occur 12 different ways. What are the total number of all outcomes in a deck of cards? There are 52 different cards. So we've got 12 divided by 52. 12 divided by 52 equals about 0.23. So in other words, when randomly selecting a card from a full deck of cards, about 23% of the time, we can expect to pull a face card. Let's look at the next one. What's the probability of randomly selecting an ace after you've already received an ace? And we're just going to assume that you're being dealt to one card after another. So the first thing we need to ask ourselves is what's the number of ways that that ace can occur? If you've already received an ace, there are only 3 aces left. So there are only 3 ways that you can receive an ace at this point. So we've got 3 in our numerator. Now we need to ask ourselves, what's the total number of all possible outcomes? You've already received 1 card, so there are 51 cards left. So we've got 3 divided by 51, and 3 divided by 51 equals about 0.058, which we would round to 6%. 0.06. So about 6% of the time, if you just received an ace, you will receive another ace. Let's do one final example as we're just trying to learn some simple calculations for probability based on that analytic perspective. The Ohio Lottery has several different lottery games. Let's think of a very simple one. One is known as the Pick 3 Numbers game. In the Pick 3 Numbers game, you pick a number, which is 3 digits, and if that number wins, you win the lottery. You don't win a heck of a lot of money, but you win. The way it works is that there are 3 different bins of balls, and each bin has 10 different balls, 0 to 9. As those balls are getting blown around the bin, they open up a valve and 1 ball comes through. And then they go to the second bin, they open up the valve and the second ball comes through. They go to the third bin, open up a valve, and the third ball comes through. So those 3 balls are then used to create the 3-digit number. So the first thing we ask ourselves is, what's the number of ways that event A can occur? And we're trying to figure out the probability of winning. Well, there's one winning 3-digit number. There's only one way to win. So that goes in our numerator, 1. Now we need to ask ourselves, what's the total number of all possible outcomes? In other words, what are all of the potential winning numbers? Off to the side, let's think this out. What's the smallest 3-digit winning number possible? It's possible that there could be a winner with 0, 0, 0. So that's the smallest 3-digit number that could win. Then let's ask ourselves, what's the largest 3-digit number that could win? If 0, 0, 0 is the smallest one, the largest one must be 999. Now we can ask ourselves, how many 3-digit numbers are there from 0, 0, 0 to 999? A lot of people look at that and they say 999, but remember, 0, 0, 0 is one winning number. So there are 1,000 3-digit numbers between 0, 0, 0 and 999. So there's one way you can win out of 1,000 potential winning numbers. 1 divided by 1,000 equals 0.001. 0.001. That's 1/10 of 1%. That, my friends, is a straightforward 3-step procedure for computing some very simple probabilities. In our next video, we're going to learn about 3 different rules of probability. And once we learn those rules, we'll be able to compute some probabilities that are just a little bit more sophisticated. I'll see you in that next video. In the meantime, be safe.